Hello everyone. So from this series we'll be seeing about the working of every component, each and every component, the practical in a practical way, and also we'll be seeing the simulation. So this in this video we'll be seeing about the resistor. So yes, resistor. So we'll be seeing about what is a resistor, so how to use it, and of course the color code and how to find the resistance, and some basic concept of series and parallel. And this here comes the main part, that is the types of resistors, testing of resistors, and simulation with software. As a engineer you should know how to test a software, because of course in every PCB, that is in every motherboard and every circuits, resistors plays a major role. And you need to know how to test a resistor so that you can replace it. So let's get started. So well, the basic definition is a resistor is an electrical component that reduces the electric current. So many of us know this, but listen it properly. A resistor is a component which has a ability to reduce the current. So that's the main ability of the resistor. So that's the basic function of a resistor. So if you need to reduce the current in a wire, that is in a circuit, you will be using resistor. This is the basic function. And of course the George Simon Ohm, who proposed the Ohm's law, and the symbol for the resistance is ohm. So this is the basic idea. And so here is the pictorial representation of a resistance, voltage, and current. So always the voltage tries to move the electron, and in here voltage tries to move the electron in left to right. So as the hand like projection is the analogy of the resistance, so the resistance will oppose the movement of the electrons, so that the current will decrease. So as we know the Ohm's law, that is which states the voltage is directly proportional to the current. And if we increase the resistance step by step, and thus the current will be decreased, so that according to the Ohm's law, the potential across the resistor will be decreasing. So analogy is very important. So everything you cannot understand with, you can understand easily with the help of analogy. So in circuits we'll be using water analogy, because the movement of the current electrons is approximately, that's mostly similar to the movement of the water in the pipes. So we'll be using the water analogy all over. So next one is finding the resistance of the practical resistor. So in practical resistor we have two types, that is a 4-band code, that is in the top, and another type is a 5-band code. So most of the resistors will be in 4-band code. So the first ring, that is a green color band, as you can see here, denotes first band denotes the single digit number of the from 0 to 1. That is here you have green. So you have green for 5, so 5, and then you have blue 6, and then you have yellow. In 4-band code the third band is your multiplier, so here you can have the 10k for yellow. So the resistance of the resistor is 56, for that is 560k ohm. And finally the tolerance, so this is brown color, and the tolerance is for gold color, sorry. So for the gold color you have 5% tolerance, and for silver color you have 10% tolerance. So this is all about the color code, and you need to get familiar with these color codes so that you can design a circuit easily. You have to tell, you have to be able to tell the resistor by seeing it without this chart. So that's most important. And next we come the types of the resistors. So we have several types of resistors. So first one we use most of this in circuits, that is a fixed resistance, as you can see here, and we have variable resistance like potentiometer, rheostat, and rheostat you will be using that in the labs for changing the values of the resistance. Of course, potentiometer, I think you won't know about potentiometer. So actually potentiometer is this. In this picture you see here, this is the potentiometer. These have three lids. Actually this is used in every volume tuner, that is in the radios and in the sound system. When you turn the volume knob, actually the resistance changes. As the resistance changes, current flowing through the circuit will be changing, and of course the audio amplified will be reduced or increased based on the resistance. So every sound knob, the sound changing knob, is a potentiometer. And there is another type of a resistance, that is which depends on the physical quantity, like LDR. There is a sensor called as LDR, which is light dependent resistor. So in that device, that device resistance will completely depend on the light. So there are many types under this. You will be seeing everything step by step. So under this term, so that is LDR. Uh, yeah. So LDR is like when the light is increased, that is the when the device is exposed to light, the resistance will be decreased, and when it when it's under a low light, the resistance will be increased. So we'll be seeing in the circuits. So these are the various symbols for resistors used practically, and these are all international standards, that is ICE symbols. So then how to test a resistor? So this is a very important step for every circuit. So to test the resistor, the step 1 is analyze the color code using the chart. So you need to find the resistance, I mean the value of the resistor using the color code given. So as you can see here, this is a 4-band system, and the first color is green, and then blue, red, and of course the tolerance band, that is a gold color. So green, blue, red, and gold. So you need to find the resistance. So let's go to the color chart. So first one is green, so that is a 5, and then it is blue, so that is 6, and in 4-band system the third band is a multiplier. So for yellow, sorry, for red, that is 100. So 5 6 into 100, that is 5600 ohms. So this resistance will offer 5600 ohms, that is a 5.6k resistance. So this is how you have to find the resistance with the color code. And after finding the resistance, the value of resistance with this color code, and then you have to note that, and then you have to check the resistance with a multimeter practically. So in multimeter you have this ohm meter, so you have to tune the knob in the ohm meter so that it will show the resistance between the 2 points. And after that, in resistors, that is in the PCB, you need to place the two leads of the multimeter, which is a positive and negative. So you have to place it either side, because the resistance has no polarity. So you have to measure. So the multimeter will show the resistance between the resistor, that is you can see here. When you place the resistance, the leads between the resistors, so you can find the resistance. So if your resistance, that is the from the color code, you find that that is 5.6k, and same, if that the measured value also same, those, if these both values same, then the resistor is working properly. So of course it may have some deviations, like we have 5% tolerance and 10% tolerance. So yes, now we'll be seeing the simulation. So this is the simulation software that I'm using. This is called as this is actually a mobile app. You can also download it in your PC or laptop and you can use it. So here we can simulate different kinds of circuits. This is actually very helpful to visualize, and you can see visually what's happening inside the circuit. Here we have many devices like AC source, DC source, current source, resistors, capacitors, inductors, and ground, of course, and voltmeter, ammeter, and here you can see the ohm meter. And we have many operators like switches, lamps, LEDs, and diodes, transistors. So this is very helpful. I'm doing many of the circuit simulation in this app, and yeah, we'll get into it. So to understand, so we'll be picking some DC source, yes. So and most of us will be using the 9-volt battery. So let us adjust the volt to 9 volt, and we'll pick a resistor. This is an international symbol for resistor, and we'll pick one LED or maybe a lamp. So this is lamp and this one is LED. So this is the symbol of an LED, practical LED, light emitting diode. And now we'll be connecting the circuit. So I'm connecting the LED with the resistor in series. You can also connect it in parallel. So one thing you have to note that in every simulation software you have to ground everything into a single point, that is you have to ground it. So let's ground it. So we have 1k ohm resistor for a diode. We can also change the ratings of the diode, like a nanometer, which color you want. Let's fix it as red, and then we can simulate. Yeah, you can see the working of this, the movement of the electrons, and of course the LED is much dimmer because the resistance value is much higher. Because you can see we given 9 volt, but the potential drop, but the potential between the resistor is 1.89 volt. So the remaining resistance is dropped. So ultimately the voltage required for the bulb is not enough. So we'll be changing the resistance value gradually. So we are increasing, right? You can see the LED is not glowing because you can also see the electron movement is much smaller because we are increasing the resistance. So now we will decrease. So you can see the increase in brightness, or at one certain point, the beyond the saturation current, the LED will burst off. But if we set it into the correct resistance, that is approximately 220 or 230 ohm resistor, the LED will glow on it high brightness. So you can see the current rating, that is 31.5 milliamps is flowing through the LED, and we have 2.05 volts across the resistor. This is how you have to simulate practically. And of course you can see the waveforms also. This is a professional simulator, so you can observe the waveform here. That is you have to click the wire and you have to click this, and you can see the waveform here. 2 volts is between the resistor, that is the remaining volts dropped between the resistor. So since this is a DC source, we are getting a line. So if this is a AC source, then we'll be getting a sinusoidal wave. So this is a very useful thing. So this is very useful, so you can simulate every circuits in this. So we can also do add resistors, and so we'll be adding another resistor in parallel. So you have to change the direction, and you have to connect this point to this, and here to here. So now this is a parallel circuit. So In parallel circuit, the resistance will be decreased. Yeah, here you can see that. Also you can view the waveform, different waveforms. So the green line shows the 9-volt waveform, that is you can see here at the top. So after the resistance, the voltage has dropped, and the blue line shows the 2.07 volts. So this is how a resistor works, and basically that is used for limiting current. So that's all about this about resistors, and we'll be seeing about the capacitors and inductors, and we'll be slowly move on to the basic circuits, which will be useful to practically simulate your own circuits, and design your own circuits and fabrication. So we'll be seeing everything. So this is a channel, Unbox Your Mind. So do support us. Thank you.